Hey, welcome back. Today we have 994 rotten oranges. It says we're given an n by n grid where each cell can have one of three values. We can have a 1 for empties, 0 for empty cells, 1 for fresh oranges, these over here, and then 2 for rotten oranges. Every minute or every step, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten itself. Another way to think about it is any orange that is rotten will spread 4 directionally outwards and make the other adjacent one rotten as well. All right, so the strategy here is to start with the state. What is the starting state? Well, we have some number of fresh oranges. We also have some number of rotten oranges. For the rotten oranges, we care where it is because that's the source from which there will be 4 directional spreading. So why don't we start with that? All right. I also like to get the dimensions to start. So that's grid. All right, and we say the fresh count is going to be something. We'll grab that in a bit. We're also going to have a queue to enable left popping. And let's initialize the collections.queue. This isn't required, but you can import collections. And then from typing, import this just to make it more compatible with your local system. All right, so we have the starting state placeholders. Now let's just fill the starting state. Let's grab the starting state data. So for that, we can do for row in the range of rows, for column in the range of columns. So for every row and every cell, we're gonna take that cell and we'll say, hey, if that's, what do we care about? Let's say if that's a fresh orange, then we want to add it to their fresh count, right? And then we also care if it's a rotten orange. So if it is a rotten orange, not only do we want to know that it exists, but we also want to know where it exists. So why don't we add that? Let's do an append, and we'll append both the row and the column position of the rotten oranges. So we'll just say rotten oranges locations per step each minute. And this one will be the count of fresh oranges. All right. And at this point, I want to just print the fresh and the queue. Let's see what we have. It says the return is int, so just so it doesn't complain, let's do that. All right, so we have 0 fresh oranges. Oh no, hold on. Why do we have 0 fresh oranges? If grid of RNC is equal to 1, we, sorry, fresh oranges. Okay, we increment that. We also have 1, which is rotten. All right, so far so good. So this is fine. And ultimately, we're going to return -1 if we don't return before this line. Part 1 is done. So part 1 gets starting state. And now part 2 will be where we process each minute by spreading rottenness outwards or directionally. And the way we can do that is saying, hey, while there are fresh oranges remaining and there are still things to process in our queue, can we take the current batch of those? So this represents the count included, or the number of rotten oranges to process for this current minute. So we'll say length of queue, and we'll process each one. So for that, in range of current batch, we can say, let's take, let's just take one, which is q.pop left, and we want to go forward directionally, so why don't we say for row column in, and this will be north current column, south current column. We'll stay in the current row, but then this time go to the left column. Stay in the same row, but go to the right side. All right, and for here, there's a few things we want to check. First of all, what is our goal? What are we trying to accomplish? We're trying to see if it is within bounds, because if it's out of bounds, we don't care. If it's within bounds and it's a fresh orange, then we care, because we want to decrement our fresh count, possibly make it rotten, and add it to our rotten queue. So let's do that. If the row is within bounds, we can say it's at least 0, but not beyond the edge, and same for column. So, and it's also a fresh orange. Then we want to decrement the count to fresh. Now at this point, maybe we're already out of fresh oranges. So if fresh is equal to 0 at this point, we can just return, let's keep a track of our minutes, I'll call it steps. Let's return which we initialize to 0, so we haven't yet accounted for the current step. So let's say steps plus the current step, which is 1. Otherwise, that's all right. We'll just, make it rotten by doing that. And also, now that this is rotten, we need to add it to our rotten queue. So let's do that as well. Queue.append. And are we missing anything? So we spread out 4 ways. We acknowledge that if we go 4 ways here, we acknowledge that this is fresh. We decrement the count. So while we start at 1, 2, 3, 4, 5, 6, now we have 5. We add this to our queue, and then these 2 will be in the new queue. So the current batch size is 1 over here. When this is all done, when this for loop completes, then Q will be the size of 2, because these 2 will be the new ones. Alright, so if this current step is done, let's make sure to increment and acknowledge that. So I think this should work. When we would not get -1, or when we would get -1 is if, a fresh orange is not surrounded by any other oranges. If it's surrounded by empty cells, then even if everything else is rotten, it can never spread to our fresh orange. I think they say that here. So if this is our grid, so rotten, fresh, fresh, let's say that this is empty, fresh, 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 empty, fresh. The orange in the bottom left corner is never rotten. Right, let's imagine. We don't have to use this example, but we can, but it's a little hard to visualize, so let's do that. Yeah, so this is rotten. This will spread out this way. And then it should spread here. The orange in the bottom left corner, row 2, column 0 is ever rotten. Well, this guy is rotten. It goes 4 directionally, as in this will become, oh, I see, wait, hold on. No, okay. Okay, so this is empty, right? So 21101, gotcha. So this is rotten. So we're gonna make this rotten. That was 4 directionally. Bottom is empty, nothing to do there. Left and above is out of bounds. The only one we care about is this one. We made that rotten, so now let's go 4 directionally. So if we go 4 directionally there, then this becomes rotten, this becomes rotten. Cool. And now these two are in queue. And then if we go 4 directionally here, this is empty, so we don't do anything here. I see, and this is safe. All we do is make that rotten, and that's in the new queue, and then in the final queue state, we do that. And this one is safe, and this is where we return -1. Okay, that makes sense. Let's see if this works. Oh no, let's see. So, okay. So if we have just one row and we have one rotten item, I mean, well, the easiest way to think about it is we have no fresh oranges. If there are no fresh oranges, then technically it takes 0 steps or 0 minutes to make everything rotten. Minimum number of minutes that must last until no cell has a fresh orange. If there are no fresh oranges to begin with, then it takes 0 minutes. So let's do that. If fresh is equal to 0, then return 0 and submit. All right, so there you have it. Runtime, pretty efficient, think so. And once again, this is 994 rotting oranges. Happy coding. See you next time.